Hello and welcome to today's webinar entitled How AOL Accelerates Ad Targeting Decisions with Hadoop and Membase Server. My name is John Kreisa, VP of Marketing at Cloudera, and I will be your host for today's webinar. I'd like to start by covering a few housekeeping items. First, all lines will be on mute throughout the webinar. If you have a question, you may ask it via the questions panel located on your webinar console. If you are having difficulties, you can ask it directly to the panelists via the chat tool, also located on your GoToWebinar console. Slides from today's webinar will be made available to all attendees after the event, along with the recording of this session. We will have time for questions, and you may submit a question at any time during the event. This event will conclude at the end of the hour. Now let me tell you a little bit about the webinar. In the world of ad and offer targeting, speed and scalability are just about everything. In this webinar, you will learn how the changing application landscape is driving the evolution of data management technology to a new open source architecture for interactive web applications. We will start by hearing from a leading analyst at the 451 Group about 6 key drivers for adoption of open source technologies in the enterprise. You will also hear from AOL Advertising to learn how they leverage Hadoop and Membase NoSQL database technology to rapidly process operational user data to achieve sub-millisecond performance. Specifically using these technologies, they were able to analyze billions of user-related events to infer demographic and psychographic and behavioral characteristics, and make hundreds of millions of cookie profiles available to their ad targeting platform with sub-millisecond random read latency, and to keep their user profiles fresh and current. I'm sure you'll find the presentations interesting. I'd like to introduce today's speakers. Matt Aslett is a senior analyst of the enterprise software for the 451 Group. Matt covers data management software for the 451 Group's information management practice, including relational and non-relational databases, data warehousing, and data caching. Pero Subasic is chief architect for AOL Advertising. Pero works on research and development in new technologies and contextual advertising at AOL Advertising in Palo Alto. Over the past 4 years, he was a chief architect of R&D distributed infrastructure, which today comprises more than 1,000 nodes in multiple data centers. You will have an opportunity to ask both of them questions during the Q&A portion of the webinar. Also joining the panel during the Q&A is Frank Weigel, who is Director of Product Management at Couchbase. Couchbase is a new company that was created from the recent merger of Membase and CouchOne. If you have questions for Cloudera or Couchbase, both I and Frank will be available to answer your respective questions. At this time, I'd like to hand it off to Matt Aslett of the 451 Group. Matt, over to you.
Thank you, John, and good afternoon or good morning wherever you are, and thanks from us indeed for joining us today. My role here, before we hand over to Pero, obviously to hear about how they're putting Membase and Hadoop into action, is just to kind of set the scene with some context with what we're seeing in terms of the changing data management landscape. Just very quickly before we do, just wanted to mention, perhaps not everybody is aware of the 451 Group. We are an industry analyst firm focused on enterprise IT innovation. We also own a couple of other organizations, including Tier 1 Research, which is focused on the hosting and data center markets, and Uptime Institute, which is focused on the global data center industry. As for myself, I've been with the 451 Group since 2007, and as John has explained, I've got kind of 2 roles within the company. I'm part of the commercial adoption of open source practice, and also part of the information management practice, focusing on databases, data warehousing, and data caching. And it's really been interesting over the last couple of years to see how these 2 areas have really mixed together, and the increased influence of open source in the information management and particularly the data management sector. And we've been able to track this through some of the reports that we've done over those years. In particular, starting in 2008 with the first kind of major report we did looking at the impact of open source on the enterprise database market. And what we found at that point was the adoption of open source databases was widespread. So about over 30% of organizations we spoke to were using an open source database of some type. But the usage areas were primarily for things like in-house developed applications, single function applications. So whilst we saw widespread adoption, the phrase we used to describe it was that it was shallow. It wasn't. We saw sporadic uses of things like Ingress and PostgreSQL for transactional applications, but much more we were talking about MySQL for web and departmental applications, development and test environments. In that particular report, we didn't specifically focus on the analytic database space, but if we look, if we look at what was happening at that point in 2008, we'd just seen InfoBright just coming to market that year with their open source product. But what we'd primarily seen was companies like Greenplum building their closed source products on open source products, in their case PostgreSQL, and also Data Allegro, later obviously acquired by Microsoft, but at that point bringing to market a product actually based on Ingress. And we took a close look at this side of the market in a report published in 2008, where we focused specifically about the impact of open source in the data warehousing space, and also began to look at that point about the commercial implications of Hadoop. I think we'd had an eye on Hadoop for some time as a technology, as an open source technology, but beginning to look at where it was going to emerge in the enterprise. So looking, as we saw things at that point, we saw obviously other open source projects becoming much more commercially viable, things like MonadDB, LucidDB, InfiniDB, and at that point we kind of saw Hadoop as fitting somewhere in this analytic database segment. What was kind of interesting is how quickly we realized that it was much more than that. If you look at the report we put out August last year, actually market sizing the data warehousing opportunity, and as part of that we looked specifically at the impact that Hadoop was having in the market and could potentially have in the market. And based on our research there, I think we kind of really realized that it justified a segment of its own, obviously not just the Hadoop core, but also the associated projects as well. And I think that's been one of the key changes that we see, obviously looking at the landscape today compared to 3 years ago, is how quickly Hadoop has come through and kind of carved itself that niche. One of the other major changes obviously we've seen is the acquisition twice of MySQL, and that really has changed the market as well in terms of the dynamics and in terms of the concerns perhaps amongst some MySQL users, and certainly the drivers for alternative support providers and vendors coming through, represented here by MariaDB, although there's obviously more choices than that. The other obviously really significant change we've seen in the last couple of years is the emergence of the NoSQL database sector, represented by a whole group of open source database projects that have really had a significant impact, maybe not commercially to a large degree at this point, but certainly in terms of changing the view of the landscape and what options are available from an open source data management perspective. So that in particular is going to be the focus of a report that we're writing right now. It's going to be coming out in early April, looking at the role of open source in driving innovation in the data management space, and in particular assessing the drivers behind the development and adoption of NoSQL and also scalable SQL databases, as well as Hadoop alongside that. So what are the major drivers we see that are changing the landscape of the market? It really can be summed up by thinking about sprained relational databases. What do we mean by that? Well, from a kind of a medical perspective, we think of a sprain as an injury caused by something, in particular ligaments, being stretched beyond their normal capacity. And clearly this is something that we think is happening to a lot of organizations where they're trying to run their relational databases beyond the capacity for which they were designed. As you may have guessed, sprain is also an acronym. and it stands for the 6 key drivers that we see that are causing organizations to look beyond the relational database, look towards NoSQL and Hadoop, those being scalability, performance, relaxed consistency, agility, intricacy, and necessity. I'll go through each of those in turn. We're going to focus a little bit more on scalability, so I'll skip straight to performance. Now, performance is something that, particularly with regards to NoSQL, is often kind of thought of, I think, or talked about at the same time as scalability, as if scalability is how you get those performance improvements through distributed database technologies. Clearly, scalability is one way you do that, but I think it's important to note that performance, it doesn't necessarily mean scalability. You can get performance improvements by using different approaches to data management without necessarily having to go for an elastic scalable architecture. So we consider that obviously strongly related to scalability, but a significant driver in and of itself. Similarly, relaxed consistency, obviously highly related to scalability, but where we would see that as being a driver is where organizations have already made an architectural choice towards partition tolerance, and partition tolerance and scalability is absolutely a given. So therefore, the decision they're having to make is how do they enable the relaxed consistency that enables the company to maintain availability in that kind of architecture. So relaxed consistency, obviously, as I say, highly related to scalability, but can be a driver in and of itself. Agility, we see as being quite separate from the others mentioned so far, in terms of particularly amongst developers looking for a more kind of flexible, schema-free data models, and in particular alongside agile development, allows developers to just move a lot quicker, be a lot more agile in their development practices, and not have to worry about database schemas and dealing with how joins are going to impact database performance. Up front, worry about that a little bit later on. And intricacy, in particular here we're talking about dealing with complexity or complex data types or multiple data types, so dealing with structured and unstructured and semi-structured information, also dealing with complex relationships. So sometimes the interesting thing about two pieces of data is not the data itself, it's the relationship between them. So we see particularly graph databases, but also Hadoop being applied to to these kind of problems where organizations are looking to, with quite large data sets, to understand not the nature of the data itself but the relationships between that data. And so obviously that is a complexity problem that they're having to deal with. And necessity also we'll come back to a little bit later on. So with the caveat that it's just one of 6 drivers that we see, let's focus on scalability, because clearly it is one of the most significant drivers. So as you can see here, we've got clearly an obviously very simplified representation of a system stack with the hardware and operating system at the bottom, the database application, and users at the top. Now, traditionally, if an organization was faced with an increased number of users, perhaps an increased number of applications on a system, the answer to that was simply to apply larger hardware to that, go for a bigger server, and expand obviously the size of the database to as would be proportional to that. Over the last 10-15 years, obviously hardware economics have changed, and what we see is now many more organizations obviously making use of clusters, large clusters of commodity servers to get the same or even better performance, obviously for a lower cost. Another trend obviously that's gone alongside that is the increased use of web applications, and what that's driving is a much larger potential group of users, a much more diverse potential group of users that the application layer has to deal with. And we've seen changes in the application layer in terms of the application server layer, the web server layer, the applications themselves, in order to be more elastic and to cope with these increased demands coming from increased number of users. The combination of those things is that the database is itself faced with more challenges than perhaps it was before. In particular, we've got large volumes of data, we've got structured and unstructured data, and we've got real-time demands in terms of the analytics. In terms of analytics, in terms of understanding how the applications are performing, how the users are interacting with the application, in order to change the, change the application setup in order to deliver the correct results and to deliver, obviously, clearly the correct data. So, in more fashionable parlance, obviously that's a big data problem, and the issues are of volume, variety, and velocity of the data. So, how do we go about, as an organization, looking to solve this issue at the database layer, which is, fundamentally, hasn't been architected to meet either the expanding hardware footprint or obviously the volume of requests coming from the user and application tier. Well, the first thing to note, obviously, is that clearly most organizations don't respond with a single database. Most are dealing with an operational analytic database. So you have to look at the specific requirements for each of those. And the requirements we see from an operational perspective, obviously real-time transactional data management issues, dealing with that big audience. On the analytics side, obviously dealing with that large volume of data and the issue of large-scale data analysis. In terms of kind of the requirements there that are being placed on the transactional side, it's all about random reads and writes, about real-time responses, as we mentioned earlier, so with low predictable latency. On the analytics side, obviously, much more read-heavy requirements, so more of an opportunity for batch processing, and taking advantage, though, of the data locality model. It's another one of the big trends that we see is organizations looking to bring the analysis to the data rather than vice versa, and to obviously reduce the time it takes to get to the answer that they're looking for. So in terms of, obviously, to clarify in the context of today's presentation, but I'm sure you already guessed, we're talking here then about Membase on the operational side, and obviously Cloudera's distribution for Apache Hadoop on the analytics side. What they have in common, at least one significant thing they have in common, they're both architected to scale. They're both architected to fit within that modern application stack that we were looking at earlier. So much more suited to the requirements of both distributed hardware and distributed clusters and distributed audience for the applications themselves. So looking particularly at the use cases that we see for some of these technologies on the Membase side, some of the major use cases, although obviously there's more than this, but clearly operating as a persistent cache for improved performance, providing real-time data collection and analysis, acting as a shared data platform, and obviously enabling that elastic scale out to respond to changing demands. On the Hadoop side, clearly batch processing of large data sets, aggregation of mixed data sources is also important, about bringing application data together from various applications to process in its entirety, dealing with structured and unstructured or semi-structured data I mentioned earlier, and also transform and loads. I think it's important, we talked earlier about where perhaps Hadoop does or doesn't overlap with traditional analytics tools. Clearly it's something that it doesn't exist in isolation, and we do see in the early adopter use cases that we've seen, quite often organizations are looking to use Hadoop to process a vast query set, to reduce it down to something that is much more usable in a more traditional SQL analysis tools. And in terms of the target markets, and this is something where we see obviously both technologies being applicable, and one thing to mention, I'm sure Pero will go on to explain how AOL are making use of this, but clearly Membase, now Couchbase, and Cloudera obviously work together to ensure that there's connectors available so that you can use these two products and technologies in combination. And by doing so, where do we see them being deployed? Well, for enterprise applications, things like event monitoring, compliance and regulatory reporting, intelligence analysis and fraud detection. Probably most obviously at the moment also for web applications, social gaming, e-commerce, clickstream analysis, and as Pero obviously is going to go on to explain, in particular, ad and offer targeting systems. But before I hand over to Pero, just wanted to finish off our SPRAIN acronym by looking at the last letter, which is necessity. It's interesting, you know, when you look at the leading NoSQL projects and the emergence of Hadoop and all the various tools alongside that. I think it's you know, when we're talking to some of the kind of the more traditional incumbent data management vendors, it's often you hear them trying to dismiss NoSQL and Hadoop as being kind of developer toys and, you know, developed out of open source communities. It's kind of people scratching a technology itch. And I think it's really important to recognize that actually these were projects and products that were developed by large businesses, large organizations, because the existing data management vendors simply weren't supplying technologies and products that were suitable to their requirements. And in particular, you know, I think this is highlighted by, we've got a quote here from Werner Vogels, the CTO of Amazon, explaining why Amazon created Dynamos. They couldn't bet the company, they couldn't bet Amazon on someone else doing that for them. They had to do that themselves. And we've seen that obviously here, you see with a lot of other organizations. And interestingly, even where we have some of these products being developed by you know, more traditional startup companies, the involvement of user organizations has been much greater than we've seen before. So, you know, MongoDB, for example, you know, actually been created by former executives at DoubleClick to create the product they wish they'd had when they were at DoubleClick. And with Membase itself, obviously developed really very closely with Zynga and other organizations to make sure they're fitting their user requirements. You know, in a way that I think we haven't seen before, and it wouldn't have been possible without open source. And this is really another example as well of where open source is often, I think, dismissed as not innovating, and it just kind of is used to copy existing products. And I think, you know, with NoSQL and with Hadoop, it's really one of the prime examples there are that open source is being used to actually innovate products that the existing vendors simply weren't delivering. You know, that's not actually clearly a good sign in terms of the data management market. And if we look again at a further quote from Werner at Amazon saying, you know, actually these organizations shouldn't be doing this. It's not, you know, obviously ideal that they're having to develop their own data management platforms instead of focusing on what it is they do, you know, their businesses are. And clearly that's why I think we've seen them, you know, engaging in open source projects so they could share the development of those projects, and also clearly why we've seen the emergence of you know, a new group of vendors to bring some of these, to commercialize some of these projects and to bring them to market and to provide support for customers of those technologies. And I think, you know, perhaps we've now seen a point where the data management market has kind of reset itself. And, you know, for this next generation of users that are looking for, you know, scalable data management platforms, there'll be the likes of Cloudera and Couchbase and others who are going to supply them with the products and technologies they need, so that they no longer have to develop them themselves. So that's just a brief overview there. Obviously, as far we see the market evolving and what we see happening in the market. So I'll hand over now to Pero to give us an overview of how AOL is actually putting some of these products actually into practice.
Thank you, Matt. Let me just check the controls. I still don't seem to have the control.
Hi Pero. John here. Just give it a click and see.
No, it's not working yet.
Okay. We can certainly advance the slides for you in absence of that.
Okay, that's good. Oh, it's working now. Okay, thanks. Thank you, Matt, and thanks to Cloudera for having me here today. This is a great opportunity for us today all to present our findings and experience to a growing community of Hadoop and NoSQL users. My name is Peros Subasic, and the past 4 years I've been working in the role of Chief Architect for AOL Advertising R&D, specifically for large-scale analytics team based now in Palo Alto, California. This presentation is about combining Hadoop and Membase for faster ad targeting decisions in our ad serving systems. Here's first an overview of the presentation. First I'll say a couple of words about online advertising in general to put things in context, and for those not familiar with this rapidly growing and changing area. There are definitely several important aspects of online advertising that make systems like Hadoop and Membase extremely appealing for this kind of setup. I will talk about large-scale analytics team at AOL, its mission, evolution, as well as R&D and technology focus and how it maps to its goals and mission. We'll then overview evolution of architecture and data flows over the past 4 years and how the present platform came to be. We'll focus on how the major pieces of architecture map into major goals of the large-scale analytics mission. And after overview of the architecture, we will be ready to overview current use cases of Hadoop and Membase. And going forward, further decreasing time needed for analysis and intelligence extraction, we are seeing a convergence towards a new kind of architecture where central roles are played by efficient data flows, caching, and large-scale storage and analysis solutions. And in the next slide, we will outline the major components and interactions in this emerging architecture. We will also outline some future features that would make this architecture even more appealing from standpoint of performance and interaction with surrounding architecture components. Finally, we have a specific use case of near real-time contextual segmentation of users that we want to share with you. And I will conclude the presentation and open up the Q&A session. Here's a brief slide, that sort of briefly illustrates the business of online advertising. The major players in our business are publishers, advertisers, and internet users and intermediaries such as advertising networks and recently also ad exchanges. Advertising network like advertising.com, for example, purchases in advance publisher inventory which is used for ad serving, and advertisers create campaigns on advertising networks which can be of CPM, CPC, and CPA type. With targeting rules, and advertising network charges them for matchmaking services. Advertising network's revenue is directly dependent on its capability to make qualified decisions in the ad serving process, so there is a clear optimization component to ad serving. Given additional publisher and advertiser constraints, this qualifies the problem as constraint optimization problem, and AdLearn is the system used for optimization for AOL advertising ad serving. It is technology developed by a team of scientists and engineers over the past 12 years, and it dates back to advertising.com times. Its main goal is to maximize revenue at the network level given constraints from publishers, advertisers, and businesses, and some of these constraints are listed here on the slide. So where does fast decision making with large and diverse data come into play in this picture? Well, much of the decision making in AdLearn is driven by machine learning components, and machine learning algorithms derive their accuracy from a large number of relevant features. Feature selection process is data heavy, and high quality and diverse data sources often lead to features and signals that significantly improve the models and consequently the prediction power and revenue. Companies that manage to acquire, analyze, and use large and diverse data sets in the most efficient way are bound to come ahead in this market. So to summarize, efficiency and reaction time play a major role in the Internet. User interests, advertising campaigns, publishing sources, and other sources of data change rapidly with great impact on the system's advertising performance. With advent of advertising exchanges, competitive nature in making qualified decisions in real time is even further emphasized. So these two factors, making qualified decisions based on large, diverse data sources and making them fast in near real time, are major drivers for us in developing systems we will be talking about today. A little bit about the large-scale analytics team at AOL. Our mission is to explore and analyze large data sets for more efficient ad targeting and optimization. It's pretty simple. We started on this mission in 2007, and starting from scratch, we grew to a team of 20 scientists and engineers with expertise in a varied range of scientific and technology disciplines, ranging from economic theory to data mining, machine learning, information retrieval, distributed computing, and software engineering. A couple of words about the data. The data belongs typically to three major categories: ad serving logs, content, and third-party data. Ad serving logs can further be split among 4 different providers internal to AOL: contextual, advertising, behavioral, premium, and ad network. Here we're looking at about 4 to 5 terabytes of compressed data per day, or about 4 to 5 billion ad serving events per day. We are looking per latest ComScore data at about 190 million unique users per month in the US, and we see on the systems on the order of more than 500 million cookies per month worldwide. Content data is active content from AOL owned and operated properties, and currently it's at a level of about 1 to 2 million documents or content pages per day that are classified on our platform using Hadoop. Third-party providers are external data aggregators, industry partners, and other sources from the Internet. Research consists of 3 major areas: analytics and insights, predictive modeling, and contextual analysis, matching, and segmentation. We'll revisit these when we talk about system architecture and how it evolved to support some basic operations for these 3 areas. Typically, the output of the initiatives is a data set that is used to improve AdLearn optimization, user session data, or insights for our sales and marketing or business teams, and similar purposes. In terms of technology, so this is definitely a technology talk, so we'll talk in more detail later about the technologies used, but this is just a short list of technologies that emerged as essential for us in the past 4 years. First, we use several components from Cloudera Hadoop ecosystem, which is Hadoop distributed file system, MapReduce framework, Flume data flows, our serialization format, and we're looking at UZ workflow manager. We are For distributed caching, we've been using Memcache and Membase extensively. As database MySQL, we are experimenting also with some recent NoSQL databases. We use for model building and CPU-intensive tasks message passing frameworks like MPI, and are always exploring new approaches, especially related to cloud computing, queuing, workflow tools, and other message passing frameworks like Erlang and so on. Here we got to the point that we can talk about backend architecture and data flow. Backend architecture, obviously, as any other architecture, starts with data feeds that come from the web servers. These are event-serving logs. And we use a small cluster for Flume ingestion. After trying a couple of different solutions, we settled on this one. And in the current scenario, Flume flows are supported by 2 Memcache instances for reliability and recovery. Flume collectors run on a dedicated cluster, collecting and aggregating ad-serving data from 4 different sources. They pass data directly to Hadoop cluster, which is actually split into 2 clusters, storage and processing cluster. After multiple infrastructure upgrades and taking into account multiple different backup scenarios and options, Hadoop storage cluster came out as the most feasible option, especially taking into account cost and bandwidth between storage cluster and the processing cluster when you use, for example, this CP for distributed power copy. Most recent data is pushed to both clusters at a time. We grew Hadoop cluster initially from 2 to 4 nodes with a heavily sampled data set, 1 in 10,000, to more than 600 instances today with aggregate storage of 2.5 petabytes and full data sets. Hadoop cluster also fetches data from the internet, like content pages and some other data from third parties, and so aggregates everything together on HDFS. And typically, a result of most Hadoop pipelines and workflows is a set of actionable data that goes directly to ad serving. Now, over time, your business requirements and expectations tend to increase, and the number of Hadoop jobs and workflows also increase. Their complexity increases, and to facilitate faster pipeline completion, we introduced a caching cluster, initially with Memcache, later with Membase, and we'll talk about some of the specific use cases shortly. These enabled us to set up efficient staging area for smaller data sets to be shared across jobs or processes across clusters. We experimented with MySQL cluster as well and a couple of commercial solutions before settling with Memcache. And we still use, as a part of this cluster, single MySQL instances to store reporting data like outputs of insights for Insights and Analytics platform. In terms of data volume and latency, this is a very good combination because Hadoop cluster and caching cluster complement each other really well in that respect. Combined in-memory storage of caching cluster has grown from about 10 to 20 gig to more than 1 terabyte today. Compute cluster is the next cluster we introduced for running CPU-intensive tasks such as CPU-intensive machine learning jobs, model building using, for example, latent Dirichlet clay allocation or parallel random forest algorithms on top of MPI. I/O being fairly modest, it is easy to stage data from Memcache or Membase as well as put the outputs back for consumption of Hadoop jobs. This cluster is used for building distributed search indexes as well, using Solr and Sphinx, and supporting full text search and matching jobs running from Hadoop cluster and hitting this search complex. Again, much of the data orchestration between Hadoop jobs and search processes happens via caching in DB cluster. And today we are also going to explore this missing link here, and that's the link between Flume ingestion and Flume and data feeds and caching cluster, which we are looking forward in the future to implement. So what is really running on these clusters? On Hadoop cluster, I already mentioned the main research topics for our large-scale analytics team. Those are reporting and insights, predictive segments, contextual analysis, and matching. On the caching cluster, it serves as a support for Hadoop, running Memcache and Membase, and as a DB support for Hadoop and front-end running MySQL, single MySQL instances. On compute cluster, we run MPI-based machine learning stuff and distributed search with Sphinx. A brief list of use cases today. Over time, really, Memcache became very popular, and we would start a project, people would start working on it. Very quickly, they would come to us and say, well, we want another Memcache instance spawned, and we want to use it for our project, and so on. So this is, I think, a fairly comprehensive list of some of the use cases. The first one is data set enrichment, where given a field in a data set stored on HDFS, we can enrich our event logs, for example, by adding related fields like mapping media IDs to campaign IDs and to advertiser ID, following that chain up to as much information as we need. It serves also as a blackboard for inter-process or job communication in both directions, sharing information between Hadoop jobs, between MPI jobs, or between MPI and Hadoop jobs in contextual segmentation pipelines. One interesting use in that respect is for predictive modeling, where we can load per campaign models into Memcache to be used for large-scale scoring in Hadoop jobs. Larger map side joins where Hadoop distributed cache and in-memory process or task cache is insufficient. Then aggregations with large number of item lookups, for example, user-level contextual profiles aggregated from visited pages and contextual profiles of those pages stored in Memcache. I already mentioned Flume integration for data flow reliability and recovery. And one of the key pieces in most of these, especially for predictive segments that have key impact on ad optimization and decision making, is segment generation, which is currently run 100% through Hadoop pipelines and uploaded into server-side Membase for targeting. However, there is a strong tendency to move closer to ad serving, and that's what motivates thinking about new architectures to reduce segment generation time. So here's a proposal of really real-time framework, and we already experimented with quite a few pieces of this framework, and they seem to be falling into place really well. We are proposing this approach called capture, compute, and forward, where essentially data feeds are again loaded through Flume ingestion process directly to Membase in say 15-minute bursts, and once loaded, the bucket with most recent 15-minute burst is used in read-only mode as a staging bucket by parallel jobs running on compute cluster. So the first part where we load the 15-minute burst into Membase is called capture, and the second is called compute. Depending on the job, output is written back to Membase as input to subsequent job or longer-term staging, or to HDFS for backend processing. In a real-time ad serving scenario, aggregated user data is flashed via tap interface to another Membase instance at the ad serving end to enrich its live session data. With proper capacity planning, this scenario enables segment generation serving without data ever touching the disk. And obviously, the data and process orchestration and execution are critical here. You still keep Hadoop in the loop because you want to do some batch processing on the larger data sets and provide more accurate targeting to your ad serving logic. So, for example, results of computations in Membase can be flushed out to Hadoop and aggregated with the existing results and passed on to the ad serving logic on the front end, typically for longer term and larger data volumes. Features ahead, what we're looking at right now and what we are looking for and hoping we can get in the next versions of Membase are bucket lifecycle management, capability to create, size, and depose buckets, asynchronous stream with all mutation operators, then iteration through key space without knowing keys in advance. Today we need to preload the keys and then basically from a local object iterate through keys and look them up in memcache. Then regex or range-based key iteration for finer-grained key space control that would enable us to read and write to different data sets and accomplish workflows actually using Membase as a storage backend. Then we want to have the capability to drain buckets to HDFS, completely empty them out and dispose them or make them available for the next level data load. We also want to be able to do event-based synchronization between Membase instances, between ad serving and backend instance through TAP. And finally, there is this is a one use case for real-time contextual segmentation, which sort of further details the previous slide and the approach. Again, we load the current active event frame, the last 15 minutes of data, into Membase, and on compute cluster we spawn a user to content ID mapper, which is a process that reads user event logs from active event frame and figures out what pieces of content a user has seen by collecting content IDs for that user and pushing it back to Membase as a UC map. On the other side, from Hadoop, we get constant updates of content ID to segment map, and this map is changing as content is generated on different properties at the rate of about say 40,000 created content pieces per month across AOL today. This is a sort of slow changing map, and map is pushed to Hadoop as incremental updates are made and Hadoop pushes it further to Membase. Hadoop is kept in the loop also to enable scaling of content segmentation to web scale as we go beyond O&O properties into broader advertising network. Now, user segment mapper takes the output of the UC map and content ID to segment map and produces user to segment short-term map. That basically contains user's profile of user's activity in the past 15 minutes tagged with specific categories and weights. And then it's forwarded on to Membase and ad serving logic. Again, Hadoop is kept in the loop for longer term updates or daily map updates. This is almost the last slide. There's some rough capacity estimates I was trying to throw in just to make sure that we have enough space for projected data volume and processing bandwidth. In terms of data volume, we are at the rate of 5 billion events per day. We're looking at 60,000 events per second, which is about 55 million events during one 15-minute burst. At 1K per event, we are looking at about 55 gigabytes for staging frame and 55 gigabytes for loading frame. Those are two buckets that need to be pre-reserved on Membase. So that's about 110 gig. Assuming we have 10 nodes with 128 gig of RAM each, that's about 1 terabyte of cache. So we have still 800 gigabytes for data output from various processes running on the cluster. As of the processing bandwidth, assuming modestly that cluster supports about 200,000 operations per second, we have 60,000 put operations reserved for loading the current 15-minute frame, and we have still remaining 140,000 operations per second for jobs to run on. These are really ballpark estimates, but if you go to this Membase link, you can do a more precise capacity planning with some overheads for metadata and so on. Finally, closing remarks. These are really exciting times. We are looking forward especially to Membase and Couchline integration and Couchbase and real-time MapReduce framework. We're also starting a partnership with Cloudera since September last year. We are working with their engineers on implementing different plugins for Flume data flows, also setting up our infrastructure on the East Coast data center. So definitely there's big need for pushing real-time decision making and ad serving further towards ad servers, making it faster, and there is definitely technological capability within reach. With that, I'll pass control on to John for Q&A session. Thank you.
Thanks very much, Pero, and I'd also like to thank Matt for your presentation today. Let's move quickly to questions. There have been a number of questions coming in the question panel, and I'll remind you, you can use that to ask questions at this time. There's one quick question that I think I can clear up, which is related to Flume. What is Flume? Flume is an open source project for reliable streaming data loading into Hadoop, and that's a component that Pero is using. It's part of Cloudera's distribution for Apache Hadoop. So it's a software solution. It's an open source software solution, Apache licensed for loading data. Let me shift to another question for, let's see, picking from the list. So a question for Pero. Can you compare this system to the previous solution you were using for doing some of these processing loads?
Yeah, that's a great question. I think we actually, there's a huge value we're adding with this large-scale analytics project, and that's that we are starting to get user profiles into the picture. Previously, if you look at the size of the logs, we were not really able to process that using the previous infrastructure, and I don't want to mention any vendors at this point, but essentially when I joined, there was infrastructure more sort of like in the style of 90s, with large data warehouses and so on. We were having problems getting the data, flowing the data through the system, and over time we realized that that is not the way to go and that we need to do something radically different. And that's what we came up with. To an extent, we are realizing every year as we go, it's much more important to move data through the enterprise and extract intelligence as the data is moving through it than to store it, ETL it, store it in the data warehouse and then repeatedly query it.
Great. Thank you. Large number of questions, so I want to apologize in advance. We're not going to be able to get to all of these questions, just looking at the time. We will go a few minutes over if my presenters can hang with me for just a minute or two. Matt, question for you. What are your thoughts on consolidation in the NoSQL space? You see any dominant solutions, or what are some trends?
Yeah, sure. I think given the large number of projects there are in the NoSQL space, consolidation has been expected in terms of the commercial suppliers, and obviously we've seen that with Membase and Couch One forming Couchbase. And I think that's good for the potential adopters in terms of getting the combination of those two companies will bring together a product which actually puts together two good technologies that will come from different directions, and the combination is definitely greater than the two individual parts. So we do expect to see more consolidation. I think there's been definite interest from some of the incumbent data providers, data management providers, in terms of as I mentioned, these are technologies that they haven't been able to respond to. So clearly, M&A is one way to do that. At the same time, though, I think we will see the projects, the community, the open source side continue to proliferate. I think we see, particularly because the code is open source, combinations of technologies, both database backends and some of the search technologies as well, and different combinations being put together. So I think we'll continue to see proliferation on the project side. In terms of the commercial suppliers, I think it will pretty quickly we'll see a core group emerge that are suitable for adoption from an enterprise level.
Great, thank you. Let me answer quickly another question that came in, maybe for those who joined late. We will be posting the slides to SlideShare, as well as making a recording available of the webinar. So it will be possible for those of you who joined late to go back and hear the entire webinar, and as well to see the slides. Let me shift to you, Pero. Question for you. You mentioned Uzi, but we didn't see it in your illustrations. Can you give a little bit more detail about what's planned for Uzi?
Yes, we are moving currently from R&D infrastructure here on the West Coast to East Coast infrastructure in Dallas, and we're sort of first trying to move existing workflows without Uzi, which traditionally we haven't been using Uzi in the past 4 years. But then the teams are now investigating use of Uzi for monitoring and instrumentation, as well as setting up workflows, and I think that will be a part of the future production environment.
Okay, and I think given the time, we have just one more question, and I'll toss it back to you, Pero. This question: how much time did you spend in implementing the solution you have now?
Well, if you look at all the solutions in our workflows, that's about this 4 years we've been working on it from scratch. But if you look at this isolated, Membase case, we've been building this case slowly over the past 2 years by sort of experimenting with different components, and then you sort of also test different systems and try to figure out which ones work the best. It seems so far that Membase and Memcache are fitting the bill the best. So, I can't really say it's a part of the research, and maybe finally when you realize how you put all these components together, that's fairly quick. But it takes some time to really figure out what components you need to include and how.
Great. Thanks very much for that. And with that, I want to go ahead and conclude the webinar. I want to again thank Matt and Pero for presenting, and on behalf of Cloudera and Couchbase, I would like to thank everybody for attending today. Again, we will be posting slides and a copy of the recording of the webinar for your review to the appropriate websites for Couchbase and for Cloudera. Again, hope you have an excellent morning and afternoon, and take care.